5G E2E networks have four outstanding capabilities over 4G networks. The four capabilities are ultra broadband access, massive IoT connectivity, ultra reliable low latency, and the last one, fourth one, E2E network slicing. Ultra broadband access is the earliest 5G application scenario and also the focus of operators nowadays. Here, in this 5G E2E network architecture, under this figure shows the 5G E2E network architecture with which outlines the 5G E2E network. The same picture is shown in figure 1 also, 2, 3, but highlighted the similar features. The base sessions are mainly concentrated for the transition of 3G to 4G due to bottle neck bottlenecked wireless communication from base stations. However, while transcatting from 4G to 5G, the EC architecture of 5G network has much more significance because in the 5G network, the base station is not the main bottleneck. The figure 1 shown below describe the architecture of E2E developed 5 Huawei for 5G. Here, this is architecture of E2E in 5G. Here, service level. First, here, secure network and service management. Secure network and service management. Service level. First one, service level. E2E secure service orchestrate. Slice 1 automotive factory. Here network level. This is service level. Here network level. Here slice 1 automotive factory. VNF. These all are VNF. Here and then slice 2 IoT. VNF. Network operating system also. After that, resource location, resources and functional level, resources and functional level, programmable control, programmable control SDNC, programmable control, wireless and fixed access, edge cloud, wide area network, WAN, core central cloud. So this is programmable control SDNC, programmable control. Architecture of E2E in 5G. This VNF stands for Virtual Network Functions. Network slicing architecture. Several autonomous service level agreements are being offered by network slicing architecture in order to meet the necessities. A network slice can be categorized into two categories. One for RAN network slice subnet instance NSSI. One for RAN network slice subnet instance NSSI and the other for CNN NSSI. Yeah, first one RAN network slice substance instance and other for CMM NSS. A slicing network can be provided several various services at a time, and the network slicing network and the service are independent. The figure 2 below shows the 3GBV diagram of slicing network. The 3GBV specifications of slicing network have been described in a detailed. The 3GBV specifications are mentioned in the figure below from 19. Here, business layer, BL, operators, third party, enterprise, verticals. This layer contains operators, third party, enterprise, verticals, remote surgery, tactile internet, automated driving, smart grid, network slice 1, 2, 3, 4, management and orchestrated mapping, NSFM, SDM, and CM. Is general in management, orchestrated MANO. MA for management, NO for resource orchestrated. MAN management, O for orchestral. Okay, network function layer NFL having control plane, user plane, and configuration. Infrastructure layer having virtualized resources, network, compute, storage. NFV and SDN dedicated physical infrastructure, network, compute, storage. And radio access network, edge cloud, core cloud control. These all are under network slicing architecture. Then VEPC network functions. VEPC is a network and stands for Virtual Evolved Packet Core. Virtually Evolved Packet Core. Virtual Evolved Packet Core is an outline for switching and processing data for mobile networks. Multiple virtual network functions, VNFs. Virtual network, multiple virtual network functions virtualize the functions of LTE Evolved Packet Core EBC. The reductions in the construction cost and the ability to quickly deploy service environments are offered by virtualization. The function of LTE Evolved Packet Core EBC are compared with the components Evolved Packet Core VEPC in the figure below. Here, VEPC architecture. Here, this is AUSF authentication N12, N13, N8. This one connected to UDM. Here, N12 connected to AMF. AMF connected to NSSF. And then this is mobility access. So from here N1, N2, from N1 UE connected, N2 RRH PBU, NG RAN connected. Here this UDM connected to SMF, SMF connected to UPF. Then it is connected to PPU RRH UE, and then this side connected AFDN. Here this SMF connected to PCF MF, UDM connected to AUSF. This is subscriber data HSS. Here N10 connected to SMF, N14 connected to UPF. Here these NEF SPA applications. From here to here, C-plane service based architecture SPA. This PCF connected to AF having DN. N5. So subscriber data HSS. This is session. This is policy. is N4, N6, N3, N22, N2. Here, SPA applications, C-plan service-based architecture. SPA, service-based architecture. Then, next one, NFP menu, management and orchestration. Orchestration. Okay. Management and orchestration, short form, MAN, MAN for management, O for orchestration. So, management of organization MENO are a significant component of European Telecommunication Standards Institute ETSI network functions virtualizations NFV architecture, and they published the NFV system architecture framework. Management and orchestration MENO coordinates network resources, the life cycle management of virtual network functions VNFs, and for cloud-based applications and network services, and it's an architectural framework. It's shown in figure based on the ETSI framework. Many open source organizations have developed their own NFV MENO frameworks. ESTI NFV architecture. Here in this architecture, this line main NFV reference points, execution reference points, other reference points, OSS, BSS, connected to OSMA. This area, NFV management and orchestration, NFV orchestration connected to VNF managers and VIMS. Here, ORVI, VI, VNFM. This is also over VNFM. Here NF, VI, VNF, VNFM, NFVI, here EM1, EM2, EM3, VNF1, VNF2, VNF3 connected as shown in figure. Here OSS, BSS. So, and next 5G mobile network architecture design. Figure demonstrates the system model that incorporates the design of the network architecture for 5G mobile networks and all IP model for wireless and cellular network interoperability. The architecture contains a computer terminal which plays a crucial role in the current structure, and a number of independent, self-reliant radio system technologies. Any of the radio approach technologies is noticeable in each terminal due to an IP hyperlink to the outside environment of the internet. However, through radio access technology RAT inside the mobile terminal must have a separate network interface. For example, if there is a need to reach 4 separate RATs, we need to provide 4 different approaches to similar interfaces inside the mobile terminal and make all these interfaces active at the same time so that the architecture can work properly. Functional architecture of FFG. 5G terminal, GPRS, HG, 3G, WLAN, LTE, here streaming server, data server, server for real-time communication, control system policy server. So this is the functional architecture of 5G. 5G architecture based on NGMN envision. Based on the envisions of NGMN, the architecture of 5G is presented in figure 8, which leverages conceptual separation between software and hardware. APIs are given to support multi-use scenario and business model. The architecture is demonstrated in figure below from architecture of 5G. So here this is use cases, business models, value proposition. Here connected E to E management and orchestration. So here business application layer